Hello my dear children of class 11 science. Today we do again continue with the chapter surface tension under unit number 7. Okay. Now in today's class we do one of the important topic related to the topic that you learned in the last class. The topic that you learn is capillarity. And in related to this capillarity there is a topic that we discuss now is capillary rise and derivation of ascent formula. Okay. Now you have learned in details about the phenomenon called capillarity, and even you know what is capillary tube. Okay. Now you know that when the capillary tube, that is called very fine bore tube having small diameter, is dipped in a liquid, there is a rise or fall in the liquid level of liquid inside the tube. Okay. Or there is a depression of liquid, or there is a horizon of liquid, okay, inside the tube, and that depends upon the nature of liquid in which the tube is dipped. Okay, and this phenomenon actually you learn as what? Capillarity. Now this concept of capillarity can be observed exactly in the similar manner like when we dipped a tube in a liquid. Now from this capillary rise we can even derive a formula known as ascent formula. Now from this formula we actually measure the surface tension of the liquid. Even we measure the surface tension of the liquid in terms of the height in which the liquid rises or depressed. Okay, but in this case we are dealing actually with the capillary rise. So definitely there is a rise in the what? There is an increase in the height of the liquid in the inside the capillary tube. Now you know which is the liquid which in which the tube is dipped into that liquid has there is a rise in the liquid level inside the tube? Water. Because water is that liquid, okay, which weight the glass, and the liquid which weight the glass, okay, when the liquid which weight the glass, and when tube is dipped into that liquid, there is always a rise in the liquid. Okay, but this rise in the liquid, okay, can be expressed by the formula that is called ascent formula. So the first part of this topic we try to understand what is capillary rise. Okay, so for that we take a very clean capillary tube made of a what? Glass. So this is a very clean capillary tube made of a what? Glass. So let me just show you that this is what? Cleaned, okay, glass tube. Clean glass tube, and this glass tube is also called what tube? Capillary tube. Capillary what? Tube. And the tube which we take should have a uniform what? Diameter, so that it has uniform what? Radius also. Means the area cross section throughout the length of the tube must be what? Same. So this tube, okay, having a uniform bore of radius, certain radius, it must be dipped into the liquid, and we can take just a liquid like say water. So I am taking the liquid is like water, but not necessarily it is on, we have to take water on it. It can be of other liquid where there is a capillary rise occur inside the tube. Now as I said, this tube has a uniform bore of certain radius, and that radius I consider as r. So I write on, let small letter r be the what? Be the radius. Be the radius of what? Uniform capillary glass tube. Okay, so I've already considered children that small r is the radius of this uniform bore capillary glass tube, and this tube must be dipped in a liquid like we have considered the liquid like say water, and that contained in a what? A glass beaker. So as a result of this, what happened? There is a meniscus which is formed inside the tube. Okay, and this liquid meniscus will be a concave meniscus. Okay, so let me just show you with the help of diagram. So there is a meniscus which is formed. Okay, and this meniscus is a what meniscus? Concave meniscus. So let me just give the name of this meniscus say as A, okay, E, B. So I am just giving randomly by using the alphabets A, E, B. So this is the meniscus which is formed. So these are all the liquid, and this is the free surface of the liquid. Okay, so what type of meniscus which is formed? A concave meniscus. Now as you know that every liquid has a what? Tension called surface tension. Even this liquid in which the capillary tube is being dipped, okay, even has a what? Surface tension, and I consider that surface tension is say T. So children, surface tension can be represented by capital T or it can be capital S, but I represent by you can letter capital T. Okay, so capital T be the what? Be the surface tension. Okay, this is the surface tension of the liquid. So what is the surface tension of the liquid in which the capillary tube is dipped? Capital T. Now under this case we will observe inside the tube, this capillary tube, the formation of liquid meniscus. Okay, and this liquid meniscus in the tube is along a circle of circumference. So this tube is usually a cylindrical tube having radius r. So there is a meniscus which is formed along the whole surface of the tube. Okay, and this is actually given by the circumference of the what? Circle. Now every circle has circumference, and you know what is the circumference of circle? Given by 2 pi what? R. So let me show with the help of dotted line the circumference of circle. So this is the circumference circle with this is r. R is the radius. So this dotted line which I have shown in the diagram is the circumference of the circle in which the liquid meniscus has been formed inside the what? Tube. So I consider that 2 pi r is the what? Circumference. This is the what? Circumference of a circle. Circle in which the liquid meniscus, okay, I am writing meniscus, in which the liquid meniscus is formed, okay, in the tube. And this meniscus which is formed is actually, okay, due to the liquid which is in contact with the what tube? Glass tube. So this liquid which is in contact with the glass tube, and due to that, okay, so what happened? The meniscus which is formed is due to what? The circumference of the what? Circle. Okay. Now, as you know, due to the surface tension of the liquid, there is a force that is equals to the surface tension that act per unit length of the periphery, which the edges of the what? Edges of this what? Circumference of circle. And this force, okay, makes the liquid to exert in such a way so that, so children, what happened under this case, as I said already, so when liquid form this type of meniscus and form the circumference of circle which is equals to 2 pi r, then for every length of this periphery, we also call the edges of the circumference of the circle where the liquid is in contact with the surface of the tube, okay, then this liquid surface exert a force, and that force is equals to what tension? Surface tension, capital T. But this surface tension exert per unit length, every length of the periphery, 2 pi r of the liquid surface inside the what? Tube. And this force is always directed in such a way so that the force exert in the liquid is exerted by this direction, and the direction surface tension act in this direction. At this liquid which is in contact with the surface, okay, the surface tension direction is given by T, and this is the direction of surface tension. But the equal amount of surface tension is also exerted in this direction also, and that is also given by T. So at this liquid surface where the liquid is in contact with the wall, okay, the surface tension exerted on the liquid by the liquid on the surface is also given by T, and the direction is this side. Even the same surface tension exerted in this direction also. So these are the surface tension exerted on a unit length of this periphery of this tube, okay, periphery of this what? Tube. Now children, you know that there is an angle of contact which is always formed between the tangent drawn to this glass surface and the tangent drawn to the liquid surface in contact. So this is the tangent drawn. If I draw this as a tangent drawn and this one, then there is an angle which is formed, and this angle is marked by letter theta, and this angle is also marked by letter theta, and this angle theta, which is the tangent drawn to this glass plane surface, and this tangent which is already drawn, and we give the direction of surface tension, makes the angle, and this angle is actually measured as angle of contact. So I just consider out here that theta be the what? What is theta? Be the angle of contact. Is the angle of what? Contact between liquid glass surface. Okay. Now when there is angle contact between the liquid glass surface, okay, then as I said, the force which I had already shown in the diagram, that is equals to surface tension, okay, exerted, okay, in the direction as you can see in the figure, okay. Now the force which is directed inward, so one force due to surface tension act equals to surface tension act inward, and according to Newton's third law, as you know, according to what Newton's third law, the wall, this particular wall, okay, of the tube also exert an equal reactionary force, that is equals to surface tension, okay, per unit length on the circumference of the what liquid, and this force is act in a direction opposite to the force which is directed inward. Now this force is T, which are directed inward, and that is due to equals to surface tension exert on per unit length of the periphery of this tube or circumference of the tube. But as per Newton's third law of motion, as I said, there is a force, a reaction force exert, okay, in a direction opposite to this, the direction of the force, that is equals to surface tension. Now the force which is directed outward, you can see these are the two forces which are directed outwards, okay, this is A, okay, now can be resolved into two components. This force can be resolved into how many component? Two component, okay. Now one component will be the horizontal component, another component will be the what? Vertical component. But to know which is the horizontal component, vertical component, if this angle is theta, this angle must be what? Theta. If this angle is theta, this angle is also what? Theta. Because the two angles which are, you can see in the diagram, are vertically opposite angles. Now this force I can split now into two components. One is the component which is called horizontal component, and there is the component parallel to what? Theta angles, and there is a component which is at an angle of 90 degree minus theta. This is 90 minus theta component, and this two component is simply given by T cos theta, and this component is given by what? T sin theta. So children, look at this part, the splitting part I have done it out here. T theta component is given by T cos theta, always given by cos theta. T 90 minus theta, because total angle is 90 degree, so this theta means this is 90 minus theta, so T 90 minus theta component is given by T sin theta. In a similar manner, this T, this component, this is the component you can see, is given by what? T cos theta. T theta component is given T cos theta, and T, this finally this is 90 minus theta, and this T 90 minus theta component is given by what? T what theta? Sin theta. So there are two components of this T which is acting outward, okay, and one is T cos theta, one is T sin theta. So children, as I said already, there are two components. One is T cos theta point length on this periphery of the meniscus, okay, and there is T sin theta which is acting outward, horizontal outward to each other, okay, and that is also act per unit length of this periphery of this meniscus, okay. But out of two components, this component T sin theta and T sin theta which are acting in opposite direction and on the same line will simply neutralize each other, okay, which means the horizontal component T sin theta which act on the entire periphery or circumference of this circle will simply cancel each other or neutralize each other. So that means the net horizontal component acting on this entire periphery 2 pi r circumference of this circle will simply what? 0. But the vertical component will not be 0. The vertical component which acting per unit length so that the entire circumference of the circle, this T cos theta act vertically upward, will simply add it up. So if simply added up means the total vertical component can be easily calculated as 2 pi r into T cos theta. So this T cos theta is per unit length, which acting vertical upward. But what is the total periphery or circumference of circle? 2 pi r. And for total circumference only, this 2 T cos theta force will act. So we can calculate now the total vertical component which act on the entire periphery of the circumference of the circle, and that is given by 2 pi r, you can see 2 pi r T cos theta, okay. So this is the vertical component which has been simply added up, okay, whereas horizontal component, as I said, we simply neutralize or cancel each other. So as a result, you can see in this particular diagram, children, in this particular diagram, the liquid which rises up in the capillary tube is due to this force 2 pi r t cos theta, and this force which act vertical upward, okay, and this force act vertical upward till this force is balanced by what? The weight of the liquid also. So children, liquid even has a weight, okay, it's balanced by the weight of the what? Liquid, which act vertical what? Downward. So the rise, this formation of capillaries, okay, I mean the concave meniscus, okay, inside the tube, and the periphery and the meniscus which is formed is due to the which component force? The vertical component force, which act on the entire periphery of the circumference of circle, that is equals to 2 pi r t cos theta. So due to this, what happened? There is a rise in the capillary tube of the liquid, okay, so when that tube is dipped in a liquid. So children, I have just done the first part of this explanation, that how capillary rise occurs inside the tube, okay. Now in the next YouTube video we actually derive a formula called ascent formula, okay, and in that ascent formula you understand how we can measure the surface tension. So we do continue the next YouTube video.